A continuous time signal is defined as at every point of time, at every instant of time t. So this signal xt is defined from 0 to 9, and we have values for xt at every instant of t. For example, for at t is equal to 3.1, we will get some magnitude here. At t is equal to 3.11, we will get some magnitude at next to 3.1 magnitude. That is what both x-axis value, that is time, and y-axis value, that is x, is amplitude. Both are continuous in a continuous time signal. So in discrete time domain, the time domain is also discrete. The sample version of a continuous time signal is known as discrete time signal. So here we have seen that the time values from 0 to 9 are sampled at every 1 second. So we'll get a sample of xt at after every 1 second. So at x is equal to 1 second, x is equal to 2 second, we're getting some magnitude or amplitude of the signal xn. So this discrete the values of xt at discrete time instant are known as, the sequence of these discrete values are called discrete time signal. So if we're given like xn is equal to x is equal to -1 2 3 -2 4, and this arrow at 3 indicates that the signal is originated at 3. That means at n is equal to 0, the amplitude will be 3. So at n is equal to 0, amplitude is 3, and the other values, that's -2 is at 1, at 2 it is magnitude is 4, and at the left side of 0 there are values 2 and -1. So 2 and -1 in the left side of 0. So first element is at -1, second element is at -2. So in this way we can plot the discrete time signals. So here a digital signal can be defined as a signal which are expressed in terms of ones and zeros. So it has only two types of amplitude, either 1 and 0. So an analog signal can be converted into a digital signal through the process known as sample and hold circuit and quantization. So what happens when an analog signal is given to the input of sample and hold circuit, it performs sampling operation on the analog signal and produces a discrete signal by creating some samples at certain instants of time. So this discrete time signal have amplitude which is varying with time. So at different instance n, it has different magnitude. So after that, the signal is given to the quantizer, where a threshold is set. Threshold is set to compare the amplitude of xn. So suppose when the amplitude is positive, that is greater than 0, xn is greater than 0, then we label this magnitude as +1 here. And when the amplitude for these samples are less than 0, then we after comparing the magnitude with 0, here 0 is the threshold, so when compared with 0, we found this magnitude are less than 0, so we assign them as -1. So -1 represents the level 0 here. So level 1 and level 0, two types of level are there, high and low levels. So these type of signals are known as digital signal. So in a computer we generally use the digital signal or digital pulse signal. The periodic signal, so a continuous time signal that exists from -infinity to +infinity is periodic, and they are everlasting signals. That means they repeat up to +infinity, from -infinity to +infinity. And for a periodic signal they must be repeated, and the t must be finite. So here if we see that this portion of the signal from -2 to 2 is repeating up for every time period t is equal to 4. So minus 2 to 2, t is equal to 4, the duration is 4 seconds. So there is a pattern having 4 seconds which is repeating after every 4 seconds. So here t is equal to 4 and it is a finite number, and since it is repeating, so it is periodic signal, and the periodic signals last from minus infinity to plus infinity. But whereas in this signal you can see that it is not repeating. The signal have a duration of 3 seconds, 0 to 3 seconds, but it is not repeating, so it is a periodic signal or non-periodic signal. A signal which satisfies the property 2, that is, it has a time period t, and not satisfying the rule 1, property 1, that is, it is not repeating from minus infinity to infinity, then it is known as semi-periodic signal or switch periodic signal. So a semi-periodic signal is also a periodic signal, but not the vice versa, that is, an aperiodic signal cannot be a semi-periodic signal. The time period t is given as 2 pi by omega naught, where omega naught is the angular frequency of a sinusoidal signal, also written as omega naught is equal to 2 pi f naught. So properties of time period t is it must be finite, and t can be a multiple of integers, like t can be 1, 2, 3 or any integer value. T can be a multiple of pi, so t can be pi, 2 pi, 3 pi or anything. T can be a multiple of rational numbers, so any rational numbers too, like it can be fraction also, so 2 by 3, 3 by 5, which are not integers but a fraction but rational, those can be also time period. T can be in this format also. And when t can also be a rational multiples of pi, so t can be 2 by 3rd of pi, 10 by 7 of pi, or any rational number multiplied with pi. So when there is an irrational number so multiplied with the time period, then it is not a valid time period. So for this signal t is equal to 2 pi by omega, here is 1, so it is 2 pi. Here also t is equal to 2 pi only, since we check this place. So what is the coefficient of t? So that is omega, so it is 1 only, so we divide 2 pi by omega, that is 2 pi by 1 is equal to 1. The phase value is not important here. Here t is equal to 2 pi by 6 pi, or is equal to 1 by 3. Here t is equal to 2 pi by root 2, that is root 2 pi. So it is a multiplication of pi with an irrational number. Irrational. So when irrational number is there, so it is a periodic signal. A periodic signal. This signal is a periodic. And for this signal, t1 for this is equal to 2 pi by 2 is equal to pi. T2 for the second signal is 2 pi by 2 again, so it is pi. So when two signals are added like this, so we need to find the LCM of the two time period. So overall time period t is equal to LCM of pi comma pi. So LCM is the largest common multiple, least common multiple, so it is nothing but pi here. So this is the time period. So in this signal, t1 will be 2 pi by 4 by 5 is equal to 10 by 4, pi or equal to 5 pi by 2. Similarly, t2 is equal to 2 pi by 5 by 2 is equal to 4 pi by 5. Again t3 will be 2 pi by 8 by 9 or 18 by 8 or 9 by 4 pi. So these are three values. So LCM of t1, t2, t3 will be equal to LCM of 5 pi, 4 pi, 9 pi upon highest common factor HCF of 2, 5 for the denominators. So if we found the LCM above, so a number which is divisible by all the three, 5 pi, 9 pi and 4 pi is 180 pi. So the here highest common factor is 1. So 180 pi is the resultant time period of this signal having three components. So when the signals are given as a sum of two or more signals, then we can use these remarks like these formulas like if we are adding two aperiodic signals, then the resultant signal will be aperiodic. So when we are adding an aperiodic signal with a periodic signal, then the resultant also be a aperiodic signal only. So when a periodic signal is present in the some signal, so the signal should be automatically aperiodic. When we are adding two periodic signal, the output can also be an aperiodic. It is need not to be a periodic signal. Okay, so here is an example given like 6 cos 3 pi by 5 into t plus 2 sin 8t. So if we find t1 2 pi by 3 pi by 5, then we'll get 10 by 3. t2 is equal to 2 pi by 8, that is 5 by 4. So if we find the resultant t, that is LCM of these two below, so nothing but LCM of numerator 10 into 10 and 5 pi and HCF of denominator 3 and 4. So HCF will be 1, but LCM of 10 and pi is not possible since they are not in the same category. Pi is in different number, so we cannot find the least common multiple of these two. So since t is not possible, so xt automatically becomes a periodic signal. So to find the time period of a discrete time signal, let the time period be n. So we can write xn is a signal which is repeating after every capital N, which is the time period. So xn is equal to n plus minus n. That is, after n samples, xn will be repeating. So let xn is equal to e to the power j omega n. So this omega is the angular frequency for discrete time signal. So now x n plus capital N, if you write, then what happens? E to the power j omega n plus capital N. Okay, so this we can write e to the power j omega small n into e to the power j omega capital N. Okay, so this is the original signal, so it is nothing but equal to xn. So for xn equal to x n plus n, so this should be equal to this one, xn plus n should be equal to e to the power j omega n. So this part should become 1, then only we are getting xn in the right hand side. So